It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other,
where you put your knowledge to test
and battle it out with the best.
to bring out the best in you. Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your rating.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Welcome to Unacademy and welcome to Unacademy Semester Exams. We are dealing with the control systems quick revision of Chapter 3 for semester exams as a part of Lecture 6. Before this, let me tell you about myself. I am sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services and cracked GATE. You can also use my code YSK10 on your Unacademy subscription to get discount. Unacademy, let's crack it. Crack GATE and ESE with India's largest learning platform and get subscription. You can install Unacademy Learning app from the Google Play Store and you get daily live classes, structured courses, live test and quizzes, unlimited access as well. And in Iconic subscription, you get a personal coach, study tracker, mains, question and answer and all the benefits of Plus. In Plus subscription, you have daily live classes, structured courses, live test and unlimited access. You can learn from the top educators of the Unacademy. As you can see, you also have for GATE and ESE the year-long batches and different courses for different specializations. You have all the benefits of Plus in Iconic along with some special benefits. As you can see, if you want to opt for Plus, I suggest you to go for 24-month subscription. You can use my code YSK10 to get the maximum discount, and this is for a limited period of time as well. And the suggestible one is Iconic subscription for 24 months. You can use my code YSK10 to get the maximum discount for a limited period of time. So today we are dealing with the control systems chapter 3 part B. Yesterday we have seen part A where I introduced about board plot and we have solved a problem based on that also. Now today we'll solve part B. So chapter 3 is frequency response analysis. And yesterday in part A we have seen board plot, and today we'll see part B, polar and Nyquist plot. Good morning Sirisha, welcome to Unacademy. I want the rest of the students also to mark your attendance. Also inform your friends that we are going to discuss polar and Nyquist plot today, and I want every student to join the session. Inform your friends to join us. Let's wait for a few minutes so that the others also will join. Meghna, good morning. Welcome to Unacademy. Sanjana, good morning. Very good morning. Let's see if somebody is going to join us. Ravalika, good morning. Very good. So let's start polar plot. So as we have seen Bode plot, this polar plot is also a sketch of magnitude and phase angle versus frequency. So we will vary frequency from 0 to infinity and find magnitude and phase angle and plot it. You can plot this either on a polar graph or on a normal graph sheet, or you can say rectangular graph. A normal graph sheet. This is a normal graph that you use, right? So let me tell you about this polar graph first. What do we do in this? We will vary this omega from 0 to infinity and try to plot magnitude and phase angle which varies with respect to omega. So let's see that. So polar plot, we'll see what is polar graph here. Polar graph actually has some circles like this. So these are the circles that you have. Right, and you have radial lines like this. You also have radial lines here as well. There are many radial lines like this, but I'm just drawing two in each quadrant so that I can explain you very easily. Right, now this is, we'll call these radial lines. What are the things that you have now? You have radial lines. They represent the angle. So this is 0 degrees. Let's say that this is 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330, 360. And if you also can take in this direction, you also have these angles in the, so angles in anti-clockwise positive, in clockwise they are negative. You can also take it anti-clockwise. This is 0, this is minus 30, minus 60, minus 90, minus 120, minus 150, minus 180, minus 210, minus 240, minus 270, minus 300, minus 330, and minus 360. And this is what is radial lines representation. You also have circles. As I have shown you, you have circles. What does these circles represent is, they represent magnitude. They represent magnitude. You can consider any circle. Let's say this is the inner circle that I am taking. On both sides, you can say it is 0.5 magnitude. Let us say this is 1 magnitude. Let's say this is 1.5. Let's say this is 2 and this is 2.5 and this is 3. Now if I say something like, I'll just give you one polar coordinate, because you need to plot this polar coordinates. Let us take some value. I'll tell you 1.5 at an angle 60 degrees. Where does this come? You have to first look at the angle. Just remember, first you have to look at this angle 60 degrees. Where is 60? Because this is positive, you have to move in this anti-clockwise direction, and 60 degrees is here. And on this line, check the magnitude. What is the magnitude? 1.5. So this is 1.5 line. So this point is 1.5 at an angle 60 degrees. This yellow that I am showing you. Now let us say you have one more point, 1 at an angle minus 120 degrees. 1 at an angle minus 120 degrees. What do you need to check first? You need to check for the angle. Where is minus 120? Minus 120 is in clockwise direction. So you have to move in this direction. Check where is minus 120. See, this is minus 120. Now on this line, what is the magnitude here? 1. So this is the point. This represents 1 at an angle minus 120 degrees. This is how you'll mark points on this polar graph. This combination of radial lines and the circles represents a polar graph. Right? Not only this, you can also convert the polar coordinates into rectangular coordinates and plot it on the normal graph sheet. You can also plot it on the normal graph sheet. Right? So this is a polar graph. Now how do you determine gain margin, phase margin, gain crossover frequency, phase crossover frequency? Because any plot, the reason for plotting anything is to find the stability. So you should know the stability of the system. So first we will understand stability. That is nothing but, how do you find the stability? It is from the gain and phase margins. Right? Now let us check that. So first I'll tell you again. I'll just revise what is gain crossover frequency. I'll just roughly revise this. Phase, which you have already learned previously, phase crossover frequency, gain margin and phase margin. Right? Now if you see this, what is gain crossover frequency? It is the frequency. If you vary frequency from 0 to infinity at some frequency, that is at gain crossover frequency, magnitude of G into H is equal to 1. Right? You will not consider dB because we are not plotting it on a semi-log sheet. I am not considering dB. It is just similarly magnitude is equal to 1. Now at another frequency somewhere, which is phase crossover frequency, at that frequency you will get phase angle of G into H is equal to minus 180 degrees. Phase angle of G into H is equal to, Nikhil Chakravarti, good morning. Varsha, good morning. Welcome to Unacademy and welcome to Control Systems course. Now if you have any doubts, you can ask me. Now, so this is phase crossover frequency. It is a frequency at which the phase angle is minus 180 degrees. It is a frequency at which the phase angle is minus 180 degrees. Now, what is gain margin? Gain margin is denoted by kg, or you can also write it as gm, and phase margin by gamma or pm. So gain margin is equal to what? 1 by magnitude of G into H at phase crossover frequency. And what is phase margin? It is 180 degrees plus 5 at gain crossover frequency. Right? So these are gain crossover frequency, phase crossover frequency, gain margin and phase margin. Hope these things are clear for you. Now let's move on to this plot. Now if I say I have a plot I have a plot like this. I have a plot and we also have circles. Let's consider one circles here. Let's consider just 2 or 3 circles, that's enough. So let's say this is the polar graph. This is the polar graph. Now I'm just drawing it. Let us suppose this is the unit circle and you got a polar plot something like this, right? These are radial lines. Now, how do you find gain margin? It is gain margin is equal to 1 by magnitude of GH at phase crossover frequency. So what is that magnitude? Is this line, if you see, this is minus 180 degrees line, this is plus or minus 180 degrees, right? This is 0 degrees, this is 270 degrees. Now on this line, just check the point of intersection of this polar plot with minus 180 degrees line. Check point of intersection of polar plot with minus 180 degrees line, radial line. And if you find the distance or this magnitude, this is nothing but this GH at phase crossover frequency. This is the magnitude. Let us call it as K, right? So gain margin is equal to 1 by K. We are finding this is the phase crossover frequency, right? Minus 180 degrees is the phase crossover frequency. And at this point we are finding the magnitude, that is nothing but gain margin. This is how you'll get gain margin. Now let us see how do you find phase margin from the same. I'll consider this plot in the next page. And see how do you find. Now this is the graph. Now how do you find phase margin? Is you need to find phase margin. What is phase margin? 180 degrees plus phase angle at gain crossover frequency. What is the gain crossover frequency? It is a frequency at which this is the frequency at which magnitude of G into H is 1. I'm just speaking of this GC, gain crossover frequency. So first you need to know that, let us say this is the unit circle, this is the unit circle 1, and it is intersecting this point, this polar plot at this point. So what do you need to find? You need to find point of intersection of polar plot with unit circle. Previously what we have done, we have found the point of intersection. Here what we have found, point of intersection of polar plot with negative real axis or minus 180 degrees line, nothing but. Now we have, then if you just find this point and find the magnitude, that is nothing but the gain margin. Now if you find the point of intersection of polar plot with unit circle, in both the cases you need to find the point of intersection of polar plot, but to find gain margin with negative real axis or minus 180 degrees line, to find phase margin with unit circle, then Once you find that, join these two. Then join origin and the point of intersection that you have found. This will give you one angle here. This is an angle, right? And you need to measure the angle with respect to this axis. This is 5GC. So this is 5GC. So phase margin is equal to 180 degrees plus 5GC. So this is how you will determine phase margin, and this is how you will determine gain margin. Hope you have understood this. Yes, if you have understood, please let me know. Yes or no, just tell me if you have understood gain and phase margin. This is how we determine gain margin. Hope you have all understood that. Do you have any doubts? Yes, no. So let us try to take one question from. Yes, sir. Okay, very good. So let me take one question. The question says that let's take one. Yeah, one previous university question papers. Yeah, consider the question given here is this. So this is the question. The question says that a unity feedback system having an open loop transfer function. Understood, sir. Very good. Very good, Varsha. G of s is equal to k by s into 1 plus 0.5 s into 1 plus 4s. Sketch the polar plot. Question is sketch the polar plot. And the continuation of this is and determine the value of k, so that first one is gain margin is 20 dB. Gain margin is 20 dB. Second one, phase margin is 30 degrees. Phase margin is 30 degrees. So let's just, for time being, just forget about this. We'll only sketch polar plot first. I'll tell you how do you sketch a polar plot. Then we'll see how do you find the value of k, right? So to solve this, the first step is write the given transfer function is in time constant or standard form. But it's already given in time constant form, so you can write directly what is g of s is equal to k by s into 1 plus 0.5 s into 1 plus 4s. This is the first step, right? Now second, let k is equal to 1 and s is equal to j omega. Substitute s is equal to j omega. First write g of s. What is g of s is equal to k? K is 1 by s into 1 plus 0.5 s into 1 plus 4s. Now substitute g of j omega. So g of j omega is equal to 1 by j omega 1 plus 0.5 j omega 1 plus 4 j omega. Clear? This is the second step. Now third step. In third step, write magnitude and phase angle. What do? You need to write magnitude and phase angle. So we know g of j omega is equal to 1 by j omega into 1 plus 0.5 j omega into 1 plus 4 j omega. What is the magnitude? M is equal to mod of g of j omega is equal to 1 by under root of omega square, under root of 1 plus 0.5 omega whole square, under root of 1 plus 4 omega whole square. This is magnitude. So what do you get from this? 1 by root omega square. You can cancel this. Omega under root 1 plus 0.5 omega square under root of 1 plus 4 omega whole square. And then we will write the phase angle. What is the phase angle? You know that, right? In the numerator you get 0 degrees by j omega. Yesterday we have seen the same thing, 90 degrees into tan inverse 0.5 omega into tan inverse 4 omega. So you can write this as minus 90 degrees minus tan inverse 0.5 omega minus tan inverse 4 omega. So these are the magnitudes and phase angles. Now you also need to determine the corner frequencies. Fourth step, corner frequencies. Although you do not need them exactly, but you can do that. What are the corner frequencies? You know, you can write, you are given already g of j omega. G of j omega is equal to 1 by j omega into 1 plus 0.5 j omega into 1 plus 4 j omega. So take these two terms, 1 plus 0.5 j omega and 1 plus 4 j omega. So what is that? I told you, you need to consider this as t, and these t should be in decreasing order so that omega will be in increasing order. So this is t1, this is t2. So what is omega c1? 1 by t1, 1 by 4. You can take it as 0.25 radian per second. Omega c2, right? 1 by t2, that is 1 by 0.5, 2 radian per second, right? So these are the two corner frequencies. Now we should vary this corner frequency and find the magnitude and phase angle. So fifth step, what you do is, you can take any values, do not worry about it. I'll just consider one table. First one is frequency, first row, second row will be magnitude, and third row is phase angle. So consider 4 to 5 different values. So let's say this is omega. Let's say this is 1, 2, 3, 4 and 5. Let's consider only 5 values. Now this is magnitude and phase angle versus frequency. So this is frequency in radian per second, this is magnitude, and this is phase angle. So let's write those values. What is the frequencies? We can consider it as 0.3. I'll consider 0.3, 0.5, 0.8, 1 and 1.2. We can consider values around these two. So this is 0.3, 0.5, 0.8, 1 and 1.2. So you can consider any values around these corner frequencies. So I have considered this. And to these corner frequencies, hi Raju, welcome to Unacademy. You need to substitute this 0.3. So let us do that. What is the magnitude? M is equal to, we got 1 by omega under root of 1 plus 0.5 omega square under root of 1 plus 4 omega square. Now substitute omega values. 0.3, first substitute, at omega is equal to 0.3. Now if you substitute, you get M is equal to 1 by 0.3 under root of 1 plus 0.5 into 0.3 whole square under root of 1 plus 4 into 0.3 whole square. So you can find m value as 2.11. You'll get m value as Amit Kumar Pandey. Going to give GATE exam ME. Very good. Hello Amit Kumar Pandey. All the best. All the best Amit Kumar Pandey. All the best Amit. Rock the exam. Give your best in your GATE exam. Amit Kumar. Very good. All the best. So at next, the same m is equal to 1 by omega under root of 1 plus 0.5 omega whole square under root of 1 plus 4 omega whole square. Now at omega is equal to 0.5, find m is equal to 1 by 0.5 under root of 1 plus 0.5 into 0.5 square. I want any one of you to tell me these answers. 4 into 0.5 whole square. So tell me what is the value of m here at 0.5. It is, what is the value? Varsha, Sanjana, Ravalika, Nikhil, Sirisha, Meghana. M is equal to 0.87. Yeah, 0.867. Yeah, 0.87 you can take it. Very good, Sanjana. M is equal to 0.87. So this is for m is equal to, so omega is equal to 0.5. Now let's substitute m is equal to, omega is equal to 0.8. Substitute. So m is equal to, we know 1 by omega under root of 1 plus 0.5 omega whole square under root of 1 plus 4 omega whole square. Now you need to substitute that omega is equal to 0.8. So m is equal to 1 by 0.8 under root 1 plus 0.5 into 0.8 whole square under root 1 plus 4 into 0.8 whole square. What is the value of m? 0.8, 0.346. Oh yeah, 0.8, 0.35. The value you can take it as 0.35. Ramchandra Kumar, hello, good morning and welcome to Unacademy. Now the last value, the last two values, 1 and 1.2. Let's also substitute 1 and 1.2. So for m is equal to 1 by omega under root of 1 plus 0.5 omega square under root of 1 plus 4 omega whole square at omega is equal to 1 radian per second. Magnitude will be 1 by 1 under root 1 plus 0.5 into 1 square under root 1 plus 4 into 1 square. So what is m value? So 1 it is 0.22. Yes, 0.22 or 0.216. Very good, Varsha. Very good. Now let's take for m is equal to, for omega 1.2, omega under root of 1 plus 0.4, sorry, 0.5 omega square under root of 1 plus 4 omega square. Now at omega is equal to what? At omega is equal to 1.2 radian per second. Substitute the value 1 by 1.2 under root 1 plus 0.5 into 1.2 square under root 1 plus 4 into 1.2 whole square. You get m is equal to 0.145. You can take it as 0.15. So these are the magnitudes. Similarly, let's also try to find, Varsha, for 1.2 it's not 3.48, it is 1.45. 0.145, that's correct. Varsha, recheck the calculation once. Sanjana, correct value. Now, so let's write these magnitude values in this. So what are the magnitude values that we got? For 0.3 it is 2.11, for 0.5 it is 0.87, for 0.8 it is 0.35, and 1 it is 0.22, and this is 0.15. Srinivas Naik, good morning. Welcome to Unacademy. Now let's also try to find the phase angles now. What is the phase angle that we know? We got phi is equal to minus 90 minus tan inverse 0.5 omega minus tan inverse 4 omega. So tell me the phase angles at omega is equal to 0.3, phi is equal to minus 90 minus tan inverse 0.5 into 0.3 minus tan inverse 4 into 0.3. Tell me what is the phase angle. Next, at omega is equal to 0.5, phi is equal to minus 90 minus tan inverse 0.5 into 0.5 minus tan inverse 4 into 0.5. What is the phase angle value? Next, at omega is equal to 0.8, I want you to calculate minus 148.5. Yes, 148.5. Can I write it as minus 149 degrees? That's it. So very good. Minus 90 minus tan inverse 0.5 into omega. Omega is 0.8 minus tan inverse 4 into 0.8. Tell me what is the phi value here. For 0.5, 167. Yeah. So for 0.5 it is minus 167 degrees. Very good. Varsha, what is the value for 0.8? Sanjana, for 0.5 it is minus 167.4. That is very good, correct. 167, I'm just taking it as approximate value. Minus 184 for 0.8. Yes, minus 184. Very good. Next, let's also do for at omega is equal to 1 radian per second. What is phi is equal to minus 90 minus tan inverse 0.5 into 1 minus tan inverse 4 into 1. Tell me this value of phi. Now at omega is equal to 1.2 radian per second. Monis Khan, hello. Hello Monis Khan, welcome. Hello sir, hello Monis Khan. So phi is equal to minus 90 degrees minus tan inverse 0.5 into 1.2 minus tan inverse 4 into 1.2. So what is this phi value? 1.2. So this is for 1 it is minus 192.5, that is correct. I'll write it as 193 minus 193, and for 1.2 199. 199.1, so you can take it as minus 199 degrees. Right, so you can write these phase angles here in this. Now if you write these phase angles, what is the phase angle for 0.3? We got it as, for 0.3 we got minus 149, for 0.5 we got minus 167, for 0.8 we got minus 184, for 1 we got minus 193, and for 1.2 we got minus 199. Right? So with these values of magnitude and phase angle, we can plot a graph on a polar graph sheet, or if you want to find its rectangular coordinates, you can also do that. This is magnitude and this is phase angle, which is nothing but it is m at an angle phi. These are polar coordinates. These are polar coordinates. Now how do you do this polar coordinates? How do you just write this? See, the value that you need to write, the first value is, let's write it like this. I'll start from this last value. Yes, we'll write these values. Now let's write these values. The first value, this value at 1.2, it is 0.15 at an angle minus 199 degrees. You need to write this magnitude and this phase angle. Similarly, the second value 0.22 at an angle minus 193 degrees. Next, third value 0.35 at an angle minus 184 degrees. This value 0.87 at an angle minus 167 degrees. I think you are not able to see this. No, this value. Now what is this value? You can write 2.11 at an angle minus 149 degrees, right? So these are the values, polar coordinate values. Now you can convert these values, into rectangular coordinates. You can convert this into rectangular, you can convert this into rectangular, convert this to rectangular, this into rectangular. You know how to find this rectangular coordinates. So let me also try to write these values in a rectangular form. So let's take the same table. So you have the first and second and third, and you can split this as magnitude 0.3, 0.5, 0.8, 1 and 1.2. Now I'll write these values. See, now the same omega value will be same omega. And what is this first value that we have taken? 0.3, 0.5, 0.8, 1 and 1.2. Soumya, good morning. Welcome to Unacademy. Here you'll have real part. Here you'll have imaginary part. Because when you are converting r at an angle theta to a plus ib, this is rectangular form which has a real as well as imaginary part. So you'll have a real part and the imaginary part. And when you try to convert this 0.15 at an angle minus 199 degrees, you can convert this into rectangular form and you would get minus, you'll end up with these values like this. Let's see. I'm just writing the rectangular values here. This is point minus 1.8 plus j minus 1.09. So write this value here. This is minus 1.8 minus 1.09. You need not write j. The second value will be, it is minus 0.85 minus j.2. So we can write this as minus 0.85 minus 0.2. Now third value, if you just try to convert this value, you would get, I'll write these values, I'm just checking them. So it is minus 0.35 plus j 0.02. So write this as real value is minus 0.35 and imaginary is 0.02. Now at 1, if you just write this value, it is minus 0.21 plus j 0.05. So write it as minus 0.21, 0.05 is the imaginary value, and the last value you can write it as, it is minus 0.14 plus j 0.05, the same value got it approximately. So this is minus 0.14, imaginary is 0.05. So this is how you can convert. These are rectangular coordinate values and these are polar. This is magnitude and phase angle. This is real and imaginary part, right? So I'll just show you at one place all this. Yeah, this is the value. So using these values, you can plot using these values. I'll just tell you, yeah, using these values which we have obtained from this table, you can plot the graph on a polar graph, and using these values which you have converted to rectangular, you can draw the graph on a normal graph sheet or a rectangular graph sheet. Either of that you can do it. It does not matter. Either you can go for polar graph or a normal graph sheet. Now let's try to plot them. I'll just take one polar graph. I'll draw it and then we'll try to do that. So I'll draw this immediately after this. So let me take these circles. So let's consider this. So these are the magnitudes, right? I think you know this. These are the magnitudes. And if you draw the radial lines, this is 0 degrees. Let's say this is 30, or I'll just take 60, 90, 150, 180, 240, 270, 330. Let's take this, only these values. So this is 0 degrees, 90 plus or minus 180. You can also say this is minus 270, minus 90 or plus 270, right? Now tell me, how do you do that? Let's take this as 0.5, this as 1, this as 1.5, and this as 2. Now what are the magnitudes? What is the first value? 0.1, 2, 3, 4. So you have to take something like this. It is, so you'll have a very small value, 0.1. You have 0.1 and 0.2, 0.3. So let's consider this values in a different way. So let's try to change these values. Now I'll take this as, let's say this is 0.1, 0.2, 0.3, then you have 0.8. So I'll just consider this as 0.8. So let's try to plot them. How do you plot them? Look at this. What is the first value? 0.15, 199 degrees. So first you need to take this angle. That is 199 is approximately 200. So this is 180. This is 240. You can say some line here. This is a, you'll have that line on the polar graph. This line is a 200 degrees line. Let's say this is 200 degrees line. And is it minus or plus? Minus. So you have to come from this point, right? So 0, 90, 180. So this will be the line. You need to consider this line. So this is plus 200. This is minus 200, right? Minus 200.15. On this, if you consider this is 0.1 circle, so this point is 0.15. You need to mark this point. This is on this minus 200 degrees. What is the first point? Minus 200, 0.15. So 0.15 is this radius circle, because there is 0.1. Now let's consider second one. Minus 193, 0.2. Minus 193. Let's take some line here. Let's say this is minus 193 line. And this is 0.2. On this, you need 0.2. So this circle. So this is the point. Next we have 184, 0.3. I'll consider 180 and 0.3. So this is 0.3, right? 180 and this point approximately. Then you have 167.8. So 167 minus 167. So this is minus 90. This is minus 180. So in between these, we'll have minus 167. Let us take this is minus 167 line. On this you have 0.8. So join all these points. So this will be the graph. So this red color that you see is the polar graph. Polar graph. Right? So this is the polar graph, and from this, how do you determine gain margin and phase margin is important. Now, how do you determine gain and phase margins? Let's look at that. Now, what you have to do is just find the point of intersection of this polar plot with this minus 180 degrees line, and at this point find this magnitude. That means this point, this circle radius, you need to measure this circle radius. So this will actually, in original graph, you get gain margin is equal to what? 1 by magnitude of G into H at phase crossover frequency. This point that you see, this point is the phase crossover frequency, and you are finding magnitude. So that is 1 by, you will actually get 0.04. You will actually get 0.04. Sorry, this is 0.44. In original graph you get 0.44. So that will be 2.27. So gain margin kg is equal to 2.27. This is for k is equal to 1. For k is equal to 1 you got gain margin. And similarly, if you want to find phase margin, what you have to do, you need to consider the unit circle. You do not have a unit circle here. Let me consider one unit circle. Let's say you also have one more circle here, and let us take this, place it on this. Let me take a little less. Yeah. Now let us say you have a graph like this, and this is let's say this is the unit circle now. In original graph you will get that, and find the point of intersection of this unit circle with polar plot, this point. Now draw a line from origin along that line. You will get some angle. This angle we will call it as phi GC. What you need to do, you need to find the point of intersection of this unit circle with polar plot, and you need to draw a line from origin through that point. So phase margin is equal to 180 plus phi GC, and you need to measure this angle with respect to this line. You need to measure this phi GC. This is the angle. So if you draw it on an original graph sheet, you'll get phase margin is equal to 180 minus 165. This line is minus 165 line. So you get phase margin is equal to 15 degrees. This is phase margin is equal to 15 degrees. Right? But what is the question that is asked? Let us check the question once. I also request you to please. This is the question. Yeah, this is the question. So sketch polar plot, that is over. Determine value of k. We have sketched polar plot for k is equal to 1. Now we need to determine k for gain margin to be 20 dB. What is the gain margin that we got? 2.27 for k is equal to 1. And what is the phase margin that we got? 15 degrees for k is equal to 1. Now if the gain margin has to be 20 dB, what must be the value of k? If the phase margin has to be 30 degrees, what is the value of k? This is what we have to determine. And how do you do that? Let's check. right? Now just look at this procedure once again and then we'll find the k value. So I'll just move on these slides. I want everyone, hope this is clear. Can you all tell me if you are clear with this plot and gain margin, phase margin? If you still need anything, I'll repeat once. Can someone tell me if you have understood this well? If yes, we will move on. I'll just move these slides. Can we? Yes, Manisha, yes sir. Meghana, yes, very clear. Yes sir. Okay. Manisha, Meghana, Sanjana, very good. Now let's just look at this procedure. I'll just move on the slides. Sir, I need graph slide. Okay, I'll just show you. Once we move on these slides. This is how we have found magnitudes at different frequencies. And this is how we found phase angles at different frequencies, right? Now let's move on to this slide. Yeah, this graph. I'll just zoom it. Now I'll just tell you this in another slide once again. Varsha, listen. Shall not take anything except this. This is how we got the graph. Now how do you find gain margin? This is minus 180 degrees line. This polar plot intersecting minus 180 degrees line indicates what? Phase crossover frequency. At this frequency, what do you need to find? See, gain margin is 1 by, let's say x, we'll call this as x, 1 by x at phase crossover frequency. Now this, if this polar plot is intersecting at this negative real axis, just find the magnitude, this circle, or you can say that this distance x, this distance is xpc. Now this is gain margin, so you know this distance and you'll find gain margin. How do you find phase margin? Is it is 180 degrees plus 5 gc. 5 gc is, yesterday I told you, phase angle at gain crossover frequency. What is gain crossover frequency? It is a frequency at which the magnitude is unity. So let us say this is unit circle. Let us call this is unit circle in the graph that you have taken. This unit circle will intersect this polar plot at a point. Yes. And now draw a line corresponding from this to origin and this point of intersection. So you need to consider a unit circle which will intersect this polar plot and join that point with the origin. And this is this angle that you measure from here with positive real axis is 5gc. So this we got it as minus 165 and this x value that we got it as 0.44. Right, this is the graph. This is how you have to get gain margin and phase margin for k is equal to 1. So if you want me to show the previous slide, this is the slide. Okay, can we move now with the question that is asked? So let me check that question once. So this is the question. The gain margin must be 20 20 dB and phase margin must be 30 degrees. Okay, Varsha, no issues. So gain margin must be 20 dB, done. Phase margin must be 30 degrees. Now, in this, what did you get? We got, in this, if you observe, we got, we'll just erase this. In this, we got gain margin is equal to 1 by 0.44, that is 2.27. So what is the required gain margin? Gain margin required is 20 dB. It is given in dB. So what you should write is, listen carefully, you should write 20 log 1 by G is equal to 20 dB. This is what we need. 1 by x, right? So you can write it as 1 by x. Let's write this as 1 by x. 20 log 1 by x is equal to 20. We already got XCA actual value 0.44, but we need to determine X value. This magnitude value we need to determine for the gain margin to be 20 dB. So what can I write? X is equal to, I'll write step by step again so that you will not confuse. So log 1 by x is equal to 20 by 21, and log base, what is this base? 10. So you can write 1 by x is equal to 10 power 1. So x is equal to 1 by 10, that is 0.1. So what is this x? X should be actually 0.1. Because we had x is equal to 0.44, we got it as 2.27, or if you write it in dB, you'll get it as 7.12 dB. So if this, because this x was 0.44, we got 7.12 dB. For x is equal to 0.1, we will get 20 dB. So to get x is equal to 0.1, what must be the value of k? To get x is equal to 0.1, what must be the value of k? Now k is equal to x value by x value. What is the x value? X value that we got now, that is x desired. Let's call this as xd. X desired by x actual. So what is x desired? 0.1. What is x actual? 0.44. This will give you 0.227. So for the gain margin to be 20 dB. So for the gain margin to be, for gain margin to be 20 dB, k must be equal to 0.227. Clear? So this is how you determine k. So once again I am telling you, you should consider the given gain margin, which will generally be given in dB. So you should equate 20 log, because this is finding dB value, 20 log 1 by x is equal to 20. So you will find x value, which is the desired x value, but the actual x value is 0.44. Desired x value is 0.1, because we need to get 20 dB. So you need to divide this desired by actual, you will get the k value. Right? So this is how you will determine the k value for a given gain margin. Now let's try to find how do you determine k value for a given phase margin. What is the actual phase margin that we got? We got phase margin 15 degrees. So phase margin actual is equal to 15 degrees. Phase margin desired is equal to, phase margin desired is equal to 30 degrees. Now you need to find what is phase margin. We know that 180 plus 5 GCF. Now let us consider actual. How did we get this? Phase margin is equal to 180 degrees minus 5 GCF was 165 degrees, minus 165. That's how we got 15 degrees. But now for this phase margin desired is equal to 180 degrees plus 5 GCF desired. So we know phase margin desired. What is phase margin desired? 30 degrees. We should know this 5 GCF desired. Right? Now what is 5 GCF desired? You get 5 GCF desired is equal to 30 degrees minus 180 degrees. What is that? You'll get minus 150 degrees. So this 5 GCFD desired must be minus 150 degrees. So what you do is, in this graph, this is minus 165, right? Here you will have minus 150. Let's say this graph is something like this is extending like this, and this line, let's say this red color line that I am drawing is a 150 degrees line from the origin actually. Now it will intersect a polar plot at a particular point, at a particular magnitude. This will intersect. I'm just trying to tell you once again. Listen. Now see, you have this one, you have a graph like this, and this was the unit circle. Let us say this was the unit circle, and you have done that, you have just joined these two, and this angle was minus 165 degrees. Now what should be this angle? It should be minus 150. So this line is minus 150 line. Let us look at this line. This line is minus 150 line. Let us say this line is minus 150 line. Now what you should measure is, you should measure the magnitude at this. That means the circle. Look at this circle. See this circle. See, this is unit circle. The magnitude is 1. This will obviously be greater than 1. So this is 2.04. You'll get in graph. Originally, you'll get this line. Which line? The minus 150. What is minus 150? It is 5 GCF desired. 5 GCF desired. Look at this. 5 GCF desired. At this 5 GCF desired, you are finding the magnitude. That is 2.04. So what is the original value? So K value you need to find. So originally this magnitude is 1, and now the desired magnitude is 2.04. So let us say this is x by x here in this case. So the original one was, and the desired one. So actually is 1, desired is 0. We'll consider this as, we'll write in terms of g actually. So let's write k value is equal to g by g. G original by d, g desired. What is g original? It is 1 unity, and g desired is 2.04. This will give you k is equal to somewhere around, you'll get it as 0.49. So this is how you determine k value for a given phase margin. For phase margin is equal to 30 degrees, k is equal to 0.49. For that, what you need to do, you need to first find 5 GCF desired, and at that 5 GCF desired, you need to find the magnitude, and you need to divide this magnitude by this magnitude. Obviously this is always 1. In any problem this will be 1. G original by G desired. Hope you have understood this. Just check this once again. Yeah, this and this. Alright, so this is one question that is generally asked in your any question that you get. Hope this is clear. If everyone is able to understand, and if it is clear, just give me some message in the chat box. Then we'll move on to the Nyquist plot. Yes, is it clear for everyone? Can someone please tell me if it is clear? We'll see what is Nyquist. Clear, sir. Varsha, very good. Nyquist stability criteria. Right? Is there anyone still who is having some doubt on this? And please tell me. See, inform everyone we are doing Nyquist plot. Students have a lot of confusion in this plot of Nyquist. So I want everyone to join the session. Inform your friends to join this session on Nyquist plot. So I want every student to inform your friends, and we are going to start Nyquist plot. I'll just give you a quick idea of how do you plot Nyquist plot with a simple problem. So do you inform your friends, and we will start this Nyquist stability criteria. So first let's see what is Nyquist stability criteria, then we'll see what is Nyquist plot. The major point here is n is equal to p minus z, where n is number of encirclements in anti-clockwise direction, p is number of open loop poles, and z is number of closed loop poles. This you need to understand. So Nyquist stability criteria says that the same thing. If Nyquist contour encircles origin in an S-plane, then Nyquist plot encircles the critical point -1 plus j0 in anti-clockwise direction as many times as number of right half S-plane poles of g of s into h of s. This is general Nyquist criteria. It's just the elaboration of n is equal to p minus z. I just don't want to go in details of this. We'll directly start a problem and try to solve this. The question is, the open loop transfer function, the open loop transfer function of a system is g of s into h of s is equal to 1 plus 4s by s square into 1 plus s into 1 plus 2s. This is the question. Determine the stability of the closed loop system using Nyquist plot, or sketch Nyquist plot and determine stability. This is one question. So let's see how do we do this. Right, so before that I'll explain you one thing. See, you have an S-plane that is you have a Nyquist contour. And how do you consider that is more important? So let's say you have S-plane like this, and if this S-plane, this is j omega, this is sigma, this is j omega, this is sigma. If this S-plane given open loop transfer function does not have any pole at the origin, you can consider this as three sections: section C1, this as section C2, and this as the section C3. So no pole at origin, then what we do, we consider three sections. Now let us say you have a pole at the origin. You have a pole at origin. You can also have pole on imaginary axis, which I am not touching, just trying to tell you now. You can take this as one section C1, this as the other section C2, and this as the third section C3, this as the fourth section C4. So in this case you will take four sections. There are many other different explanations. This is one way of analyzing this. So everyone, please do inform your friends, drop them a message, call them, tell them that we are solving Nyquist plot. So this is called as a Nyquist contour, which covers or which includes the imaginary axis and the complete right half of S-plane. Right, the complete right half of S-plane and the imaginary axis. If there is a pole at the origin, you need to neglect. If you have somewhere here, you have one more, you can neglect it, imaginary axis. So but just we are not getting into details of that. This is Nyquist contour, and you need to map this to a g of s into h of s plane. We'll map this to a g of s into h of s plane. That is nothing but the Nyquist plot. Now what to plot, to map Nyquist contour to GH plane, you can consider individual mapping, that is mapping of C1. C1 is nothing but it is a section from 0 to J. This is J omega axis, right? So it is from J0 to J infinity. That means we are varying omega from 0 to infinity and taking the locus of G of S, H of S. That becomes actually polar plot. So if you want to map C1, it is nothing but the polar plot. So you need to draw the polar plot. That is the first case. Now second case, mapping section C2. Mapping of section C2. What is this section C2? It is a section which covers right half of S-plane completely with a radius of infinity, because complete right half of S-plane has to be considered. So you will substitute S is equal to limit r tends to infinity e power j theta into r into e power j theta, right? So when you substitute s is equal to limit r tends to infinity e power j into r j theta into r, you can take one approximation as 1 plus st can be approximated to, because r is tending to infinity, so you can approximate it to st, right? And in this case, because omega is vary from 0 to infinity, right? And in this case you have c2 is traveling from j omega plus pi by 2 to it is moving to this part, this is minus pi by 2. So you can take theta is equal to, here in this case theta varies from plus pi by 2 to minus pi by 2. So this is the second part. So let's see the third part. The third part is mapping of C3. C3, if you observe, C3 is the section which is similar to C1, which is the mirror image of C1. So you can say it is the mirror image of the plot. The mapping will also be the mirror image of C1. or you can also say the inverse polar plot. Then fourth one, mapping of C4. In mapping of C4, if you observe, C4 is a very small semicircle. You can say that with a radius small r which tends to 0. So substitute S is equal to limit r small r tends to 0 r into e power j theta, and in this you can take approximation as 1 plus st is equal to 1 because r is tending to 0, s will also approximately tend to 0. So this approximation is 1, and here theta will vary from, see this is moving, I'm considering this as it is moving from minus pi by 2 to plus pi by 2. So theta varies from minus pi by 2 to plus pi by 2, minus pi by 2 to plus pi by 2. So this is how you'll have to proceed. So these are the steps, you must be very much careful. Now in this also, the first step that you do is consider a Nyquist contour. And if you observe the question, there is a pole at the origin, two poles at the origin. So you'll have four sections. So consider this. So this is the fourth section. This is section C1, section C2, section C3. Now write these values. This is C1, C2, C3, C4. This is a S plane. Now you need to write the same steps that I have written. Mapping of C1 is a polar plot. Mapping of C2, substitute S is equal to limit r tends to infinity r into e power j theta, where theta varies from plus pi by 2 to minus pi by 2. Right? Next, C3 mapping is mirror image of C1. Next, C4 mapping is S is equal to limit r tends to 0 r into e power j theta, where theta varies from minus pi by 2 to plus pi by 2. So now you should plot each and every one. So first case. So the second step will be mapping of C1. What is mapping of C1? It is polar plot. So for polar plot, you check first one is whether the given question is in time constant form or not. Yes, it is already in time constant form, given g of s is equal to 1 plus 4s by s square into 1 plus s into 1 plus 2s. Now second, you write g of j omega, that is 1 plus 4 j omega by j omega whole square into 1 plus j omega into 1 plus 2 j omega. Third one, write its magnitude. What is that? Under root of 1 plus 4 omega square by omega square into under root of 1 plus omega square into, you know this, right? 1 plus 2 omega square. Next, fourth one, write phase angle. So that is, in the numerator you get tan inverse 4 omega. In the denominator, j omega into j omega minus 180 degrees minus tan inverse omega minus tan inverse 2 omega. Right? So these are the four steps. Now, unlike we have done in the previous case, instead of doing the complete frequency response, we can consider a simple thing like this: omega, magnitude, phase angle, 0 and infinity. Just three values you can consider, two values. So omega radian per second, magnitude, phase angle at 0 and at infinity. So if you substitute omega is equal to 0, the magnitude is 1 by 0, which is infinity. Now if you substitute infinity, that will be obviously be 0. Now consider the phase angles. Now phase angle, if you substitute 0, it is minus 180 degrees. And if you substitute infinity, so that is minus 90 plus 90 minus 270 degrees. So you can say that the polar plot will be something like this. So you need to draw it both things, yeah. So you need to draw S plane and G of S into H of S plane as well. So this is section C1, you can see, and we are mapping this through this plane. This is mapping. Now what is a polar plot? Find the values. This is the value, one value. That is infinity at an angle minus 180 degrees. 0 at an angle minus 270 degrees. Now what is the angle difference between these two that you need to observe? Minus 270 minus of minus 180. Minus 270 plus 180. It is 90 degrees. Right? Now, what is infinity at an angle minus 180? This is minus 180. And infinity at an angle minus 180 is either here or here. Right? I'll just take this point here. And 0 at an angle 270. So this is minus 270. This is minus 180. So it will start and end like this. And you need to check whether it is intersecting this point or not. You need to check whether. You can also draw it something like this. See, you can take this point and you can also draw it like this. But because of the presence of a 0 in this, see, you have a 0 in the numerator, there is a chance of root locus intersecting. There is a chance of root locus intersecting this point. So that is the reason we can draw it like this, and we'll check whether this point is existing or not. Now how do you check that? This is a minus 180 degrees line. You need to verify if the phase angle is minus 180 degrees or not. If the phase angle is equal to minus 180 degrees, then we can say that it is the phase crossover frequency. Now let's do that. So consider the phase angle. What is the phase angle of G? That is phi, right? I am writing it as phi. So phi is equal to tan inverse 4 omega minus 180 minus tan inverse omega minus tan inverse 2 omega. Now equate it to minus 180 degrees. Right? Now let's see if you just try to do this. Can we cancel these two and say tan inverse 4 omega is equal to tan inverse omega plus tan inverse 2 omega? Yes. Now apply tan on both sides. Can I apply tan on both sides? Yes. Tan of tan inverse 4 omega is equal to tan of tan inverse omega plus tan inverse 2 omega. So what is tan of tan inverse? It is 4 omega. Then what is tan inverse A plus B? Tan A tan B by 1 minus tan A tan B. Tan A plus tan B by, that is tan of tan inverse omega plus tan of tan inverse 2 omega by 1 minus tan of tan inverse omega, tan of tan inverse 2 omega. That is tan inverse A, tan A plus B. You will get 4 omega is equal to omega plus 2 omega by 1 minus omega into 2 omega. From this, if you find omega, you get the value as, I'll just tell you this value. If you just simplify that and find, you'll get 0.354. 0.354 radian per second. This is phase crossover frequency. If this value is equal to 0, then this will not intersect the negative real axis as we have discussed here. But now here it is intersecting, and omega at this point is 0.354 radian per Second, omega is given, but you need to find the magnitude, right? Magnitude also you need to find. You can find this magnitude by substituting this in the magnitude. So we know magnitude of g of j omega is under root of 1 plus 4 omega square by omega square into under root of 1 plus omega square into under root of 1 plus 2 omega square. So substitute that omega value. Omega is equal to 0.354, right? If you substitute omega is equal to 0.354, what do you get? Magnitude of j omega is equal to under root of 1 plus 4 into 0.354 square by 0.354 square into under root of 1 plus 0.354 square under root of 1 plus 2 into 0.354 square. Substitute this, you will get the magnitude, that is at which point, what is the magnitude at that particular point omega, is 10.64. So you can say that this is 10.64. So you need not worry about this particular steps that I have done, 2 steps in all the problems, but in this particular problem, whenever you have a 0, you just have to be very much careful. Whenever you have a 0, you have to be careful. Now, this magnitude is 10.64, right? This is 10.64, this you need to remember. Hope you are getting confusion. So let's just remember that we are mapping C1. Forget about the rest of the things as of now. Then we will map C2. Now second one is mapping C2. So how do you map C2? You'll assume S is equal to limit R tends to infinity R into e power j theta. R into e power j theta. Now let us consider g of S is equal to, what is that? 1 plus 4s by s square into 1 plus s into 1 plus 2s. Now what I told you that was, in this you have two conditions. One is theta varies from plus pi by 2 to minus pi by 2. The other part is that here, because r is tending to infinity, you can approximate 1 plus st to st. So I will say 4s by s square into s into 2s. You can cancel this yes and yes. So this is 2 by s cube. So what is g of s is equal to now? G of s is equal to 2 by s cube. Now apply that. 2 by s. What is s? Limit r tends to infinity r into e power j theta whole cube. So that is 2 by limit r tends to infinity r cube into e power j3 theta. Can I write it like this? Yes. Now let us see. So 2 by r tends to infinity. So this is infinity into e power minus j3 theta. I have taken e power j theta to the numerator. So what happens now? This is 0 with e power minus j3 theta. So g of s is equal to 0 e power minus j3 theta. But you know theta varies from plus pi by 2 to minus pi by 2. If you substitute plus pi by 2, it is 0 e power minus j3 pi by 2 and 0 e power minus j3 pi by 2. Now what is the angle in this? This is minus 3 pi by 2. What is the angle in this? So this is minus of minus. This will be plus 3 pi by 2. Right? What is minus 3 pi by 2? Minus 270. This is plus 270. Now find the angle difference between these two. Final angle is 270. Initial angle is minus of minus 270. This will be 540 degrees. Is it a positive angle or a negative angle? This is a positive angle, anti-clockwise direction. Angle is positive angle. And how many degrees? 540 degrees. Right? Now this is what is the mapping. Now let's see. So this is C2 and you need 2 points here. So this is C2 and we are mapping this C2 from S plane to G of S H of S plane. And what did we get? We got 0 at an angle minus 270, 0 at an angle plus 270 approximately. So what is 0 at an angle plus 270? Can I say this is minus 270 and this is plus 270? And from here to here you need to move 540 degrees in anti-clockwise direction. So I should start at minus 270. I should move in anti-clockwise direction. This is 360. This is the mapping. You get this? I have started at minus 270, moved 540 and reached this plus 270. So the angle difference between these two is 540 degrees. So this is the corresponding mapping of C2. Now let us see the mapping of C3, which is very easy. Next step. Third. Mapping of C3. What is C3? If you look at C3, this is C3, right? This is C3, which is a mirror image of C1. Similarly, you can just plot it, the mirror image of C1. C1 mapping was something like this. It was this. So if you just take the mirror image of this, it will exactly be something like this. So this, the mapping of this is this. So the mapping of this is this. Mapping of C3. And you need to give the directions. The directions here was this and here the directions will be from here, right? So this is mapping of C3, which is mirror image of C1 with respect to real axis. With respect to real axis. Now let us consider the fourth one. What is the fourth one? Mapping of C4. What is the mapping of C4? How do? You will take S is equal to limit r tends to 0 r into e power j theta, where theta varies from minus pi by 2 to plus pi by 2, right? Now so let us consider g of s. G of s is equal to 1 plus 4s by s square into 1 plus 2s into 1 plus s. In this case I told you, because s is tending to, because r is tending to 0, r tends to 0, you can approximate 1 plus s will also tend to 0. So 1 plus st can be approximated to 1. So can I write it as 1 by s square into 1 into 1. So this is 1 by s square. So g of s is equal to 1 by s square. Now apply that 1 by limit r tends to 0 r into e power j theta whole square. That is 1 by limit r tends to 0 r square into e power j 2 theta. E power j theta whole square is e power j 2 theta. Now that is 1 by r tends to 0. And I'll just take this term to the numerator. E power minus j 2 theta. Can I write it is infinity e power minus j 2 theta? But theta varies from minus pi by 2 to plus pi by 2. If you have any doubts, you can ask me. Sanjana, Varsha, Meghna. No, this is infinity e power minus j 2 theta. So when theta is minus pi by 2 and theta is plus pi by 2, let's try to find the values. So this is infinity e power j 2 pi by 2. This is infinity e power minus j 2 pi by 2. So this is infinity e power j pi infinity e power minus j pi. So can I write infinity at an angle pi and infinity at an angle minus pi? Now take the angle difference from final value to the initial value. It is minus pi minus of my plus pi. This is minus 2 pi. What is the angle? Negative. What is the angle? Negative. Clockwise direction with 360 degrees. Clockwise direction with 360 degrees. Can someone just drop me a message and tell me if this is clear? Now we will draw this S plane, G of S, H of S plane. This was C4. You need to map this from this S plane. So what do you get there? You got with infinite radius, you should start at pi, infinite at pi. So this is pi, this is plus or minus 180 pi. So plus pi, infinite radius. You need to move to minus pi, the same point. In which direction? In clockwise direction. So you'll have to move in this clockwise direction and reach the same point. This is the direction. Can someone please let me know if you are clear with this concept? Now you need to draw the complete. So complete Nyquist plot is the complete mapping. So if you have to draw that, just draw the C1, C2 and C3. Yeah, this is C1, C2, C3. Yes sir, very good Sanjana. C4. This is S plane. Now you are mapping this to G of S, H of S plane. Now how is that diagram that you are getting? Let's see. So you get, first one that you got was this, right? Now second, first one that you got was this. I'm just taking this to the approximately this value. Then from this, what happened? What is that mapping of C2? See, this is from 270 to 270. So we should move from 270 to 270. And from here you got mirror image. Just look at this mirror image. So this is the mirror image. This is the mirror image. So this is the point of intersection with the negative real axis. From here you got this value. Now the direction is something like this. You can just take this direction, and from here it has moved in this direction, and this is in this direction. It is a closed path. That's what you get it. So this is the complete Nyquist plot. And what was this point? If you see, what was this point? This point was 10.64. Now where would be minus 1? It will be, this is minus 10.64. Where would be minus 1? Inside this, right? Minus 1 is inside this. So let's say this point is minus 1. Right? Now if you observe number of encirclements, what is the question? Let's look at the question. So if you observe the question, are there any poles in the right half of S plane? No. So n is equal to p minus z. So p is 0, z number of encirclements. If you see, it has been encircled in, just for convenience what you do is just draw a line from minus 1 to outside, and see in this, if you observe, there are two encirclements. This is one encirclement, this is the other encirclement, so it is 2. minus 2. So z is equal to 2, which is not equal to 0, indicates an unstable system. What is z? Z is number of closed loop poles. If only z is equal to 0, you can say that the system is a stable system, right? So this is about the Nyquist plot. Let's look at this once again from the starting. I want you to note it down. If you haven't noted it down, it's very easy. Yes, from here, Nyquist plot. This is the end of Nyquist plot, and I request you to join the session at 3 p.m. also to listen to the fourth unit, compensators and controllers design. So before that, just check this Nyquist stability criteria. N is equal to P minus Z. We will consider these contours. So this is the mapping structure. We have taken a question and try to map each and every section. C1, we found what is the point of intersection or phase crossover frequency. Then mapping of C2, this is what we got it as. Mapping of C3, mirror image. Directly we can do, you need not do any substitution, any calculation. If you want, you can do it, but you'll get the same thing. Mapping of C4, you got an infinite radius. Then finally the Nyquist plot. Hope this is clear to you, and in this session today we have learned about polar plot and Nyquist plot as a part of chapter 3, which is the end of this. So I guess you have understood this, and thank you so much Sanjana, Varsha, Meghna, Manisha, Soumya, Amit Kumar Pandey, Raju, Ravalika and Sirisha for joining me today on this session, and we'll have the other session at 3 p.m. and we also have another session at 5 p.m. on complete chapter 5. So once again, thank you all for joining me today on this session as a part of control systems chapter 3. We have learned polar and Nyquist plot. So as I always tell you, we have #1 study channels on Unacademy, you can see, and do like this video. Don't forget to share it to your friends. Like this video and don't forget to share it to your friends, and comment if you have any doubts. You can subscribe to Unacademy, use my code YSK10 to get the maximum discount, and you can click on this bell icon to get the notification of my classes and join our Telegram group for more updates. Do subscribe, don't forget to like it and share it. Thank you.